Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing thin converging lens, paper 4, classwork for extended candidates. We have question 2. I will start by question 2 is discussing convex lens, which is the other name for converging lens, used to produce an image of an object. So, according to the ray diagram we have in your question, you have to describe this image. You can say this case is the case of magnifying glass. How do you know? It's the only case we have virtual refracted rays here, and we have extension of rays, and the image is virtual. So the image is virtual. How do you know? You have extension of rays. So the rays are refracted here, okay, and you will look here, okay, so you can see the extension of the refracted rays. Describe this image. The image is enlarged for sure, and it's upright and it's virtual. Is it clear? Okay. On the figure, mark a letter E to indicate the position for an eye. I did it already. To be placed to observe this image. Please follow the instructions. Label or mark letter E. Okay, letter E, so you have to indicate here letter E at the right side of the lens. So here you have to indicate letter E. Okay, okay. State an application. So you can use this convex lens in this way. Okay, we have many uses for this magnifying glass. It could be, as I said, magnifying glass or the eyepiece of telescope. So as magnifying glass, okay, or the eyepiece of telescope. Okay, okay. So we have here, it's done. We are done with the first part and the second part. Okay, okay. In the space below you have to draw a ray diagram to locate the image when you have an object of height 1 centimeter placed 5 centimeters from a convex lens. Its focal length is 2 centimeters. So you have to draw your diagram full size, not to scale. Full size, not to scale. Okay, and you are advised to locate the lens roughly in the center of the space. Label the image. Okay, let's do this. First we have to draw the principal axis, and we will try to locate according to the advice. So we have here the principal axis, and we will draw the lens as to make it simple. Okay, I will draw the lens here at the center. Okay guys, you can draw it like this just for simplicity. Okay, try to locate from the center here, from the optical center, the focal length is 2 centimeters, so 2 centimeters at the right side and 2 centimeters at the left side. So we have here F1 and F2. Okay, where the object is located 5 centimeters from the lens. So here we have 2 centimeters and 3 centimeters here. We can place the object. Okay, so the object here is located and its height is 1 centimeter, so you have to draw it full size. So here 1 centimeter height. So here this is how you can the object and its height 1 centimeter. Now you have to draw your diagram full size and you have to locate the position of the image. I can use 2 simple rays. You have 3 standard rays, but I will use only 2 now. A ray which is parallel to the principal axis from the object. It will refract through the focus. Okay. And a ray which is passing through the optical center from the top of the object. It will be passing through the optical center from the optical center here, so it will be not refracted, undeviated, so it will be undeviated. Where the rays intersect, you can find the location of the image. Okay, as you see now, the image is formed here. And it's not 1 centimeter, it's smaller. It will be same size if the object is located 4 centimeters. Why? Double focal length. But here the object is located beyond double F, so you will find the image is smaller. So if you would like to, so here this is the image. If you would like to describe the image here, you will see the image, it's smaller and it's real and it's inverted. Okay, and if you compare its height, you will find its height is smaller than 1 centimeter, the actual height of the object. Is it clear? Okay, so this is very important. If you would like to try the third ray, so the third ray passing from the top of the object through the focus, it will refract parallel to the principal axis, and also it will intersect with the other rays here, so the location of the image is correct. Is it clear, guys? So this is very important. In other questions, maybe it's not full size, you have a scale, so you have to follow the instructions and be careful when you are calculating the scale. Is it clear? Okay, so here we answered all the points, and you have here the lens for sure. Okay, is it clear? Let's move to question 3. Question 3, we have an object and its image formed by a converging lens, and you have this drawn full size. Okay, what happened to the image? Describe the image. Okay, the image is, as you see, the image is diminished, smaller. Diminished means smaller. Okay, and inverted and formed by real rays, so it's inverted and real. Okay, On the figure, draw a ray passing through the principal focus and label the principal focus F. Okay. A ray passing through. Okay, I will do it. How you can draw this? Where the image is formed, you can draw a ray passing parallel to the principal axis. It will refract through the focus and it will intersect with the other rays to form the image. Okay, so we have here it will be refracted at the middle line here inside the converging lens, and it will be refracted. So this point is the focus. Okay, so the question is asking you to label the principal focus F. So this is F. Okay, to follow the instructions, I will not write it in words, I will just label it F. Okay guys, okay. Use the ray you have drawn to determine the focal length of the lens. Okay, here in this question you have to find the measurement using your ruler to measure the distance from the optical center. So here you have the optical center of the lens and you can measure it. So it will be 1, 2, 3. centimeters. Okay, the last part of the question, draw another ray not passing through a principal focus. Okay, how to draw this ray? So it means you have to draw an extra ray, not one of the three standard rays. Okay, not one of them. You have to draw an extra one. This extra one, you can draw it here from the top. It's not parallel to the principal focus. From the top at the midline inside the lens, it will converge and it will be refracted, converge, and all the rays will intersect where the image is located. Okay, so this yellow one, it's a light ray but not one of the three standard rays.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.